Welcome to this week's Concurrency Tech Insights series. This week, we are talking about building a manageable AI framework. We have some awesome guests this week. Let's meet them. So as always, I'm here as your host, Nathan Lesnowski. I'm Concurrency's Chief Technology Officer. And with me, I have two awesome guests. The first of those is a returning guest. This is Swami Venkatesh. He is a PhD. He is a data scientist at Concurrency, doing really awesome projects, and he's very involved in building AI foundations. Welcome to this week's podcast and conversation, Swami.
Thanks so much, Nate. Happy to be back. Looking forward to talking more, expanding on what we have done ML, and more talking about governance and how we can implement an awesome ML pipeline for people. Happy to be here.
Awesome. And then we also have Jeff Lifkowitz. He is a technical architect. He has a rich background in executive guidance on data and building out rich data environments. Welcome to this week's conversation, Jeff.
Thank you, Nate, for joining me. Really excited to be part of the conversation, and I think the audience is really going to like what we have to talk about today.
Awesome. All right, so let's dive in. So this week we're going to be talking about building a manageable AI framework. What we'll cover in that is first the life cycle and architecture. What does it mean to build that manageable AI framework? We'll talk a lot about ML ops and the part that it plays into operating a AI environment, and then also about work streams that companies typically use to implement a manageable AI environment. Next webinar, do not miss this. We will be following up on a very popular topic on December 17th on Zero Trust Security. We had a webinar probably about a month and a half ago on Zero Trust Security, and it was very well attended, very popular, and it really introduced what it meant to have a zero trust environment. In this conversation, we'll be talking about how does the company then take action to implement that zero trust environment, and what are companies doing to do so in an expeditious way as they enter into 2021. So do not miss that. I think it'll be a really interesting conversation with some interesting people. All right, so let's get into talking about today's topic, which is building a ML environment. And in front of you, you see different examples of where artificial intelligence has taken hold within the context of our businesses today. Everything from autonomous systems to building custom machine learning models to deep learning to neural networks to simple things like chatbots that are being implemented in many of the stories that we've shared over the previous webinars. Natural language processing, which has become very popular in our remote world, interacting with individuals that are purchasing a product or interacting with a human type of interaction that allows for maybe even social distancing scenarios in drive-ups, or allows for a remote experience in ordering something in a more natural way. Scenarios like virtual companions, like we talked about in our AI for Good scenario, or building autonomous systems, especially in manufacturing, where we're trying to automate the relationship with the manufacturing line and use humans in that manufacturing line for the most capable activities, or the surgical or robotic personal assistant scenarios that we're seeing in healthcare, or even cybersecurity, which are seeing with things like Azure Sentinel, where they're building capabilities into the security platform to help mitigate security risks. This is a rich platform of capabilities that are happening. It's real. Impact is being driven right now, and organizations are looking to understand, how can I then take these things that I'm building and operationalize the outcome of each of these projects and build it in a way that ensures that I'm not only built something that's very functional, but I maintain something that's functional. And I also have put the necessary guardrails in place to keep the organization safe and ethically implementing it in the right ways. So when you think about this in the context of a maturity curve, I think we think about this as arriving at this point. We often talk about this maturity curve around the Azure landscape or the cloud landscape, where people are starting to implement different activities within the cloud. They're starting to light up new workloads, but they haven't necessarily operationalized that environment yet. They haven't built the foundation to be able to build those environments within. This is about building the AI foundation. So many organizations now have built out their cloud foundation. This is about building the AI foundation, the data foundation that exists within the environment, that allows us to accelerate those impacts and then also allows us to operationalize those impacts. So where many companies are still doing manual activities or they have traditional data warehousing or they've sort of started to surface projects over here in different spots, but they haven't operationalized it to a pattern where it allows them to accelerate into these other zones because all these roadblocks exist in order for them to get action done. Some of the projects that we've started, for example, maybe the data wasn't ready or they can't pull it from their on-premise environment yet, or they haven't cleared the security barriers that have allowed them to get to that position. So our conversation today is all about building that AI foundation and what are the components of that AI foundation. So these are some of the things that we'll be talking about the idea of what is an architecture for AI services top down, governance level. What does the AI governance even mean to our organization? How do I ensure that when I've built something, that that thing is operated properly from a just availability, performance, engagement standpoint, but also that I understand what it does and how it does it, and I have governance around how those activities occur. We have an idea around the security of the approach for data that exists in ML, or ethics as it exists in ML. Like, what data am I using to make a decision? Is that data appropriate for making that decision against the regulations that are tied to our organization? And other ethical concerns about how I'm using people's information, either internally to make decisions in an ML model or externally in what I present. Creating common process models for ML ops and how I care for models over time as they age. We're also establishing normalized consumption approaches. So this is all about layering in these goals into achieving this within a program. So let's start this off by asking a question to Swami about what is a high-level data science lifecycle? So when I think about this in the context of a initiative, and then broaden that outside of that initiative, what is that high-level data science lifecycle I need to start thinking about as I make this real in my business?
Sure, and this visual kind of exemplifies everything. So our approach first to any project is first to understand the business, right? What is the problem that they're bringing to us? So that's where the start is, to understand the business. We usually bring in like BAs to come in along with us. So not only do we have the technical know-how, we also try and understand what does it take, or how the change, how do we do the change management with respect to the business, right? So that's where we start. And in any data science project, one of the first things is data. That's the beginning of any project. So we have to understand, one, what type of data do you have? Where do you have that data, and how can we use that data? Can we use that data directly as it is, or do we have to transform it, change it somehow to kind of match up with what the model is expecting the data to be like, right? And this is typically the most heaviest part of any data science project. You ask any data scientist which part he spends most time on, they will say cleaning the data. That is by far the part that we need to spend a lot of time on. And it also touches upon some of the points you raised, Nate, just a minute ago. When you talk about ethics, what type of data are we using? Is this data correct? Is this data ethical? Is this data legal? Right? I mean, those are all those concerns that we need to kind of address, and that's the stage where we address that. Along this time, once we understand where the data is present, what we also start doing, and this is something that Jeff is going to touch in just a moment with respect to the architecture, is we also start thinking about how do we get to a regular stream of data that keeps coming in, right? You don't want that, that's the pipeline part of it. So that you create a robust and reproducible framework where you can ingest this data into the architecture where you'll be carrying out all of these AI ML work. So that's where the environment comes into picture that comes next, the kind of architecture that we'll talk about in a bit. And of course, the wrangling exploration, that's the transformation of the data that we do. Once that is done, it kind of crosses into the modeling at that stage. When you start taking that data, go and do a little bit of feature engineering, do training and evaluate the model. So you try and see, does the model match up to what you're expecting, right? It does not always just happen at once. There's a whole lot of iterative approach that we take. So once you create a model, check and see how that works. You then have to go back in, maybe go into feature engineering once again, do model training, or sometimes jump back to the data bit of it, go and see, can we get some more data from some other source, and then bring that in, right? So that iterative approach is what we keep doing. At the end of all of that, once we arrive at a model that gives us the correct output, that's when comes the most important part. Like all models just don't stop at a model. You have to have that interface. Where does the business gain from this model, right? And that's where the deployment comes into picture. So you need to have all the necessary resources set up. And especially since we're moving towards the cloud, it's important to have it set up on the cloud, be scalable, and which can adapt to anything that the business throws at it. And so that's really, really important, the deployment part. And then finally, pushing it on to customer acceptance, the user acceptance testing, and then finally productionalizing and putting the model out there for people to use and the business to gain ROI out of. It's kind of in a broad walk through the whole thing.
And ultimately, this is a cycle, right? In a sense that you've deployed this to the end, but then ultimately this comes back all the way around to business understanding, cycling through again and again and again as the model ages, right?
Mm-hmm. And that's where the idea of ML ops comes into picture. That we'll be dealing a little bit more. How do we make this seamless, as you said, keep the cycle going without any blocks, and at the same time also talk a little bit how hands off can you be from this once you have the pipelines in place, once you have all of these different like resources in place. How do you get to a level that you can't get completely hands off, let me put it that way, but you can, for a certain extent, kind of automate the entire thing, and we'll be talking about some case points there as well.
Yeah, no, that's a great point. I think one thing to note too is once you get started, right, you have a model and that the business starts to see value out of it. That's where you start to get back to the beginning of the loop, right? The business understanding. You have like new data that you want to come in, you want to filter and kind of promote through. So that's why you want to kind of automate it, because you don't want to start from ground zero. You want to be able to reuse and make things easier the second time around.
Mm-hmm. And I
Build
think
upon
part
what
of our
you've built.
conversation today is like about repeatability of some of this too, right? Like, I mean, we don't have to build a new environment every single time we do a new project or things like that. So maybe this is a good parlay then into our next question, which is, what does an AI foundation look like on Azure? So when you think about, if you think about that in the context of that previous image being sort of stampable, right? Like I do one of those things, I do another of those things, I do another of those things. What are those elements are shared? What are those elements aren't shared? What does that foundation technically look like?
Yeah, I think that's a great question. And what we're looking at here is really the architecture of what exists within the Azure landscape. And the first thing that's really important is what, like we said, business understanding. Where does that data live? And one thing that we're constantly seeing with our clients and data in general is the type of data is changing, right? It could be streaming. If it's like an IoT use case, let's say it's a company that, to give an example, like makes printers, and they want to, rather than be reactive on the warranty, provide a service to make sure that they fix it, that data is coming in real time, and you need a way to make predictions on it. The data itself could be, traditional. It could be like structured in a warehouse or, on-prem, or it could be in the cloud. And what's interesting is we no longer live in a world where, any organization has one cloud that they're using. It could be an AWS or an Oracle. So it's really important to understand what the data is, what the purpose of it is, and understand from an ingestion standpoint, how am I going to get it into the cloud and make it usable for your machine learning analytics use cases. So that's really where Azure Data Factory comes in. It's really good at pulling data from multiple sources, whether that's on-prem, whether it's structured, whether that's unstructured IoT data, and putting it in multiple locations, right? You can use a pipeline to directly load to Cosmos or storage, but in terms of how you want to set up, typically you want to have a pipeline that loads into an Azure data lake, and then from there, that really opens up everything in the Azure ecosystem. So in terms of the actual platforms that you're using where you're building the models, there's two options that are great. One is Azure ML and one is Databricks. Azure ML, the big selling point is it has auto ML, so you can actually pull it in and it's really empower your citizen data scientist. But if you want to have large volumes of data and you want to have a Spark cluster, Databricks is the leading best in class in this area. You can work with up to petabytes of data. Obviously you have to increase the cluster size, but you have the ability to build models on larger data sets, and where your accuracy was lower, now you're working with a larger volume. So as a result, you can improve the model performance and do analysis on things that you couldn't do before. And there's also, what's interesting is we're seeing the immersion of cognitive services, deep learning, text analytics use cases. And what's awesome about the evolution of this, now you're able to do configurations on these services where before you would hit, like, for example, a face API to detect, okay, who is this, a male, is it a female, the age. Now you can actually configure these pre-built models within Azure to be tailored toward your individual use case. But after you have the data in Azure and actually you've built the model in Databricks or Azure ML, it's really important to productionize it. So you can actually take the model and host it in either a REST API or put it in a Kubernetes service. And this is important. Let's say you have an application that is consumer facing and it's being constantly hit. You need an ability to scale out, because a REST API that's not scalable may not work. So it's really important to productionize it. And the consumption of the data is also important. So Power BI can be connected to any one of these sources, or if you're dealing with larger data sets and you want to do analytic important, Synapse, which is a new service within Azure, really connects the dots. For example, Cosmos DB, may be used in an application because it's like a NoSQL database, but it's hard to do analytics on it. So, what Microsoft has done is they built a product called Azure Synapse, which lets you connect to Cosmos, which makes it easy to query. And it's once it's in Synapse, it makes it very versatile for doing analytics and calculations, which it wasn't easy to do with Cosmos.
Awesome, thanks, Jeff. All right, so let's move this into how all this fits into the ML ops cycle. So Swami and Jeff, tell me a little bit about how ML ops applies to the AI foundation. Like, what is that cycle that exists in that space? Once I've built that foundation that Jeff just talked about, the components of Databricks and Azure ML and cognitive services and the data lake and the ability to host the operating models in Kubernetes or in REST APIs, then publishing that out through Power BI, like that standard set of capabilities and framework. How does ML ops factor into that idea?
Perfect. Yeah, that's exactly it. I mean, imagine what we're going to see here is exactly where we took that data science lifecycle slide and the architecture slide, and how do we merge that together to form a kind of a flow chart, if you may. So that's typically what we do as far as ML ops, and Azure has got a pretty robust offering as far as this is concerned. So you have all these data sources that you can take it from. That's Cosmos, SQL, and file folders is what you've been shown on the left. You basically take all that data and then you can put it into the experiments. I mean, each one of these ML is designed as an experiment. So each experiment takes in the data, creates a model. You could either go for automated ML, so where you have like literally a framework where it takes in the data and tests every possible model that we know so far and try and see what gives us the best results. So all you need to give it is the data and what you want in the end, and the auto ML kind of does the rest for you. But if you don't want to go with that like a sledgehammer approach, it's better to kind of know, and you know exactly what you want to look at. You can even design very targeted experiments there. model that you know. Now, as Jeff suggested in the last one, you can either create your own models or you could go to cognitive services where you take a prepackaged model. And it's not that you have to depend on it entirely. You can actually refactor it to adjust to your type of data, right? So that's the power of what we can do. And all this is just that first part. You create those experiments. And then those experiments need some amount of compute to run. And that's what Azure Cloud Services is all about. When you train those models, you use the Azure ML compute. Now, with ML compute, it's not as innocuous as it sounds. You've got a choice there, right? That's what you have to recognize. Depending on the amount of data that you're going to ingest and the type of models that you're going to create, you need a scalable amount of compute. Sometimes you need distributed compute, which is where Databricks kind of comes in. But Azure ML gives you that flexibility, gives you that choice, right? You can pick and choose what type of compute that you would require. And once you have all of these, the next thing is to package them and validate. Now, this is at a stage where you're actually going in, training the models, you're creating the compute, and then you're testing it out. And once you do that, you then go in to validate, check out how good those models are. And then at that stage, once you certify that these models are good, you need to now select. Now, it's not just one experiment you've done multiple experiments. There are a number of these models. You need to make sure you validate and select the one model that fits, that one model that gives you what you want and gives it reliably. So that's the model you're going to take and package into the Kubernetes. That's the deploy and serve. And then once it's deployed and people are interacting with this, there's always a phenomenon of model drift. The model doesn't stay the same because the data that comes in, we really don't have a handle over, right? That keeps changing. And as that incoming data keeps changing, you might see a little bit of a fluctuation on the model performance, right? And this is where the idea of ML ops, the cycle, comes into picture. Because once you start seeing this drift in model efficiency, that's when you have to trigger retrainings, right? And what you've done so far is you've created a pipeline to train that model. You have the necessary scalable system where you can take, if you now want more compute, you can provision more compute, and then go ahead, do the packaging, validation, deploying, and serve. And that is where ML ops comes into picture, right? And in all of this, the best practice is any code that you've created so far needs to be stored and validated, where you need to promote a community involvement here. There's just not one person who's going to be doing all this coding, right? And that's where GitHub comes into picture. If you see, there's GitHub integration. So Azure DevOps has that built-in GitHub integration where you take all of this code, source code, and store it. And you can even create branches, have multiple people work on different branches, merge everything together, and again, go ahead, deploy it through this entire pipeline that you see here. So this is what we call continuous integration, continuous deployment kind of a model that we've created. This is well known for developers, software developers, etc. But then we get the same thing in like AI ML field as well. So that's one of the biggest advantages that we see for ML ops. So this makes this entire thing seamless. And the best part of it, what I mentioned hands-on previously, is with the monitor bit, you kind of design these checkpoints, right? If the model performance falls between a certain range, and that's perfectly fine. If it goes either above or below that, you automatically re-trigger this retraining and the other pipeline to take place. And again, the package and certify models is the other checkpoint where you test and see which model do you allow to move into the deployment phase, right? So thinking about that entire process, where once you've created a model and you've deployed that model, you're also making sure that you keep following along, not allowing the model to drift too much, and adjusting it to the type of data that you get. So that's the biggest advantage of ML ops.
Yeah, huge point. I especially appreciate like how, if we were to go back to the beginning of the presentation and talk about like the outcomes that are driven in the business by each of these ML models, how that is sometimes some of the most substantial change, or it's operating at the most substantial point of the life cycle, whether it's what inventory you're ordering, or the way you're interacting with the customer, or the way you're packaging up a statement of work that gets sent out in an automated way, or the bot that's running in the manufacturing floor. And that efficacy of the ML model and the drift that could exist in it, and the ability to monitor and cycle through and understand that this is a life cycle, not a one-time thing. Like, this is what you just said is so critical to that piece of it.
Yeah.
Absolutely, absolutely.
And I think it's also important to note, the reason why you want to automate it and have this process and have continuous development is really it cuts OpEx expense down, right? It makes it easier to, not your focus on the operationalizing of the model, but developing new models and figuring out how to make innovative use cases to improve your business and move toward a data centric organization. So that this is sort of a key, what piece to that entire picture, right? That first slide where you saw the trajectory of the curve, right?
Exactly. And this is just another example where how many times do you want to build these cycles, right?
Mhm.
Do I want to build the architecture every single time I do a new project? Do I want to build the cycle every time I do a new project? Like this is one of those scenarios where platform and foundation are really important.
Yep.
Yeah.
Gives them the guidance.
Yep.
Let's
And
hit our last topic real quick. I mean, we only got like 3-4 minutes here.
yep.
Which would be how do companies really approach building this foundation? What are the work streams that companies are using, the steps to achieve success?
Yeah, typically, I mean, again, as we pointed out, the business understanding is the most crucial part of it, right? So we have these workshops with our clients and trying to understand what is their business use case, what do they want to achieve through implementation of this AI/ML model. So once we have that captured, the process, there are multiple ways we could go about it. Center of excellence is one way to do it. Even otherwise, I mean, then we start thinking about based on the use case, what kind of architecture do they need or what kind of architecture do we need to provision, right? As Jeff comes in and then well, once he decides that, that's when you build the enterprise AI landing zone there. And at this stage, again, depends on different ways we can approach the clients want to approach is take a pilot scenario and implement that. Use that as a use case for them to see not only how this project is implemented, but also how ML ops works, but also what kind of ROI comes out of this, right? It's like a small scale testing, if you may, like putting your toes in the water. And then, of course, there are bigger picture of governance that Jeff would love to go in and talk more about there.
Yeah, no, absolutely. So it's interesting because it's not just about getting the data, putting it in there and creating a process. It's really important to make sure, especially when we're talking healthcare data, we're talking financial data, that you really lock down and you control who has access to it. So when we're doing a project, it's really important to know the groups and the level of detail that the users can access, because oftentimes it's funny. Once the platform's set up, oftentimes governance can be an afterthought, but it's absolutely critical to make sure that the right people have access to the right data at the right time. And governance is not inhibitants, but it's something that's used to protect the company and avoid risk.
And then, of course, comes the actual process where we start looking at the AI/ML consumption, build the standards, the guardrails around all of that, make it cyclable. And then once these processes go through the center of excellence, then the entire cycle is set up, right? That you have this continuous process where it takes the new data, feeds it in, retrains the model, deploys that out, and everything is monitored. I mean, that's the best part of it. You collect all of this data, and that itself is a treasure trove when you start thinking about how to modify business standards even around this process. So, which is pretty important.
Exactly. And I still feel like what this is really doing is it's readying the business to onboard into a scenario that accelerates their progress, but accelerates it in a way that is governable, manageable, that ensures the business is not only getting the right outcomes, but that it's protected. So it's a great, I want to say it's prerequisite because they kind of sometimes the cart drives the horse here, but it allows you to kind of get this going in a way that is much more structured and allows the business the ability to accelerate its progress.
That's right.
All right. So let's thank you again, Swami and Jeff. So much great insights. I want to just close with a couple key points here. These key outcomes that we covered in the front are exactly what we're trying to do here. That organizational model, the approach to bringing those forward and achieving clear outcomes for the customers in the business is exactly why we're building the foundation. And our suggestion, our strong suggestion, is that this is something that can be an impediment. Not doing this is an impediment to your forward organizational progress on AI. In the same way that an Azure foundation or a cloud foundation is an impediment to your business leveraging the cloud to achieve new outcomes for the business, the lack of an AI and data foundation in a business is an impediment to you achieving the net benefits to new revenue or operational savings that exist within AI and data. So our strong suggestion is that we follow up with this conversation with a project workshop that identifies what are those initial use cases of an organization that are looking to leverage AI. And this is no longer an aspirational thing. This isn't like, well, it's the maturity curve shows that this is like 2-3 years out. No, this is where businesses are getting real benefits, especially now during the pandemic, getting real benefits now. This is where you identify that project pilot, you identify how your governance implementation for AI and data is going to drive that project pilot in an iterative way. This doesn't have to be a big bang, but it has to be something that drives those standards forward as the pilot is implemented, and then ultimately achieves the ROI of your initial pilot, but then also readies the business to be able to achieve other net benefits from an AI and data foundation. So what we would like to do with you following this meeting, and you will see as you close the webinar today, an opportunity to be able to select for a virtual one-on-one. We would like to have a virtual one-on-one with you regarding your AI efforts, discuss where there may be funding available, talk about where there's opportunities to be able to implement a data and AI foundation that then actual real revenue opportunities are built on through those AI efforts. Let's meet on that. Let's talk about it. Let's drive impact within your company right as we're hitting this end of year and hit it as a North Star as we go after 2021. Also, don't forget to join our webinar on December 17th on Zero Trust Security. This is another one of our North Stars for 2021. And if you didn't see the webinar 2 weeks ago with Microsoft VP Brian Wilson talking about the 5 North Stars for 2021, go back and watch that. AI is one of them, Zero Trust Security is another. These are 2 initiatives that businesses must be achieving in 2021. And then, of course, you can see all the historical webinars on concurrency.com, hit our blogs on this topic, hit our videos on this topic. This is a very, very important topic for you to be continuing to educate yourself on, so do not miss that new content. We will see you on the 17th. Hopefully, we'll see you virtually one-on-one for an AI conversation. We hope you have a great rest of your day.
Thank you.